Hey guys, we are going to be continuing our conversation from Friday, 11-6 day 1. We were talking about radical expressions. We're going to continue that conversation today. So with radical expressions, you'll notice that all of the problems have a radical in them, or a square root as we're used to calling them. And Friday we were working on simplifying those and getting them down as far as we could. So what's going to happen today is basically we're going to run into the issue of we're going to be left with a square root sitting in the bottom of your fraction. And one of the biggest things that I want you guys to take note of today, and this we wrote in our 11-6 day 1 notes if you flip back, but radical expressions, you can't leave a radical or a square root in the bottom of a fraction or in the denominator. All right, so we can't leave one in the bottom. You are absolutely okay to leave one sitting in the top, but it's not okay to leave one sitting in the bottom. So on Friday, when we were simplifying these, what we talked about is that quotient property here. And the quotient property says that you are allowed to separate these out with a radical around each one of them individually. So 80 over 25, the square root of that, you can break that down and say that that is the same thing as doing the square root of 80 separately and dividing that by the square root of 25. Now, if you take a look at this, the top number 80, you can't do the square root of 80 without getting a decimal, and we are not allowed to have decimals in our answers here. So instead of writing square root of 80, you have to break 80 down. And we do that by looking at our perfect square list and thinking about, okay, well, if 80 is not a perfect square, what perfect square goes into 80? 8 and 10 go into 80, like 8 times 10 is 80, but 8 and 10 are not on our pretty list of perfect squares. So you don't want to choose 8 and 10, or even 2 and 40. Okay, 2 times 40 is 80 as well, but 2 and 40 aren't on your pretty list. So you have to go through your pretty list until you can find the biggest number on your pretty list that goes into 80. And if you go through your list, 16 goes into 80. All right, so you would do the square root of, it would be 16 times 5 would give you 80. And 16's on the pretty list. 5's not, but just one of them needs to be. Over top of, in the bottom of our fraction, we had the square root of 25, but we know what the square root of 25 is. That's perfect. The square root of 25 is 5. After that, our product property says that instead of having 16 and 5 both under a square root, we can split that up. So now I'm going to write the square root of 16 separately from the square root of 5. And then I still have in the bottom of my fraction that plain 5 sitting there. We do this because we know what the square root of 16 is. The square root of 16 is a perfect 4. We still have a square root of 5 that we can't do, and we can't break it down either. No perfect squares go into 5, so we leave it as square root of 5. Over, and then in the bottom, we just have the plain number 5. This is a perfectly acceptable answer because there are no square roots sitting in the bottom of a fraction. It's okay to have them sitting in the top. It's not okay to have a square sitting in the bottom, and we don't have that. So we're all set with number 1 then. That's as far as you could go. If you look at problem number 2 over here on the right, we're going to do the same thing here. So we're going to take that square root around the whole fraction. We're going to split it into the square root of 20 over the square root of 49 individually. Now if you look at each of these numbers, the square root of 20 is not a perfect square. We would get a decimal if we typed that in. So we have to start thinking about what goes into 20. Let's see, 2 times 10 is 20, but 2 and 10 aren't perfect squares. Let's see, 4 times 5 is, and 4 is a perfect square. So we would say square root of 4 times 5, since 4 times 5 is 20. So I'm just replacing that up top, over. In the bottom, I do know what the square root of 49 is. That is a perfect 7. So then I start breaking the top using my product property. I can write square root of 4 times the square root of 5 separately, and I still have that 7 sitting down below. Oops, sorry. And then from there, we do this because we do know what the square root of 4 is. The square root of 4 is 2. So I have 2. Square root of 5 is not pretty, and I can't break it down. So I leave it as square root of 5. Over, in the bottom, I have that 7. And I can't go any farther than that. I don't have any square roots in the bottom, so that is a perfectly acceptable answer. All right, take a look over here at number 3. And with number 3, we have square root of 4x to the 5th over 9. And if you take a look here, we've got, we can split this up. So we could write this as the square root of 4x to the 5th over the square root of 9 individually. Now we can even split this up because that's really multiplication of 4 and x to the 5th. So I can do a square root of 4 times the square root of x to the 5th over, we know what the square root of 9 is, that's pretty, the square root of 9 is 3. From there we can keep on going because we actually know what this is as well. So as I come down here to work, the square root of 4 is 2. And the square root of x to the 5th, we can break that down. Remember that any variables, if you break them down into squareds, for example, x to the 5th, that's the same thing as an x squared times x squared and then an x. Because if you add those exponents together, they add up to 5. So I just replace x to the 5th with that. And then we still have over in the bottom of our fraction that 3. We do this because up top now we have that plain 2 out front, but I can split those x squareds and put them each under their own square root, like that, and then put it over 3 in the bottom. That way my squareds and my square roots will cancel each other out. There's nothing to cancel out here because I don't have a little 2 for my x. And then I can write my final answer for this one as 2. I have an x and another x left, so that'd be x squared. This x has to stay under a square root because it didn't cancel out. And then that all stays over top of 3. So my final answer there would be 2x squared, square root of x, over 3. And again, you can see that there's no square roots in the bottom, so that is perfectly acceptable to leave it that way. All right, number 4. We've got z to the 5th over 25y squared and the square root of all of that. I can go ahead and start splitting this right now. So I can split this into a z to the 5th up top. And I'll go ahead and split this up right now and do the square root of 25 and the square root of y squared separately, just to avoid another line of work. We just talked about how to break down a 5th power, so I'm going to rewrite that z to the 5th. I'll rewrite that as a square root of z squared, another z squared, and a 5th z. So that way my exponents add up to 5. You always want to break things down into squares, that way things cancel out for you. Over top of, in the bottom, the square root of 25 is pretty. The square root of 25 is 5. And here I have a squared and a square root. I can just cancel those out right now. So I'll have 5y sitting in the bottom there. Let's see, from there, I'm going to come over here. I'm going to split a square root around each of those individually now. That's our product property of radicals. So square root of z squared, another one of those square root of z squared, and a square root of z. Over top of and the bottom, I have 5y. I do this because then I can cancel squareds and square roots out. That leaves me with up top a z and a second z, so z squared. This z, nothing cancel out, has to stay under that square root. And in the bottom, I've got 5y sitting under there. Because I don't have any square roots left, I can't break anything else down. That's where I would stop with that problem. The last one that we're going to do today is the baseball problem at the bottom here. I'm going to zoom out a second. It says, a baseball diamond is a square with sides of 90 feet. How far is a throw from third base to first base? So third base would be right here, all the way over to first base, which is right here. It says, give the answer as a radical expression. So a radical expression means that you're going to have one of these in your answer in simplest form. Then estimate it to the nearest tenth of a foot. When they say estimate, that means that you are allowed to have a decimal. So I want you to circle the word estimate here and say with a decimal. All right, so we're going to have both. We're going to have a radical expression, and then we're going to estimate that with a decimal as well. So if you take a look here, we've got, let's see, we've got that this side is 90 feet, this side is 90 feet, and we're trying to figure out this side right here. If you guys take a look here, this actually forms a right triangle. And whenever you have a triangle that has a 90-degree angle and a right one, you can use the Pythagorean theorem. So triangles that are right, you can use Pythag. The Pythagorean theorem looks like this. A squared plus b squared equals c squared. So we're bringing in a little geometry here. The A and the B, what you put in for those are the side lengths that are called the legs. They form that 90-degree angle. And you can see the side lengths in this picture are 90 and 90. So these are my A and my B. I can go ahead and plug that in right now. So I'm going to do 90 squared plus 90 squared equals, the C number is the hypotenuse. That's the side that's across from the right angle. So this is the side that right now we don't know. And if you don't know what C is, then you just have to leave it as C with that squared. From here, you can do 90 squared in your calculator, and you should get 8,100. Plus 90 squared again is another 8,100. And still, we have equals the C squared that we don't know. If you type 8,100 plus 8,100 in your calculator, you will get 16,200 equals C squared. And then we can, figure out what C is, you have to get rid of a squared. To get rid of a squared, we square root. That way they cancel each other out. So that's where those radical properties are coming into play here. If you type in the square root of 16,200, you'll get a decimal, but they said that was acceptable here. And you will get approximately 127.3 for that. And let's see, this was a distance across here, and they were working in feet. I can see that from the picture. So 127.3 feet would be an acceptable answer for number 5. All right, guys, you can get going on your homework now, and you'll have the rest of the time to work. Please make